Welcome to today's Explainer. We are going on a wild, investigative journey today. We're going to start macroscopic, right there in the grocery store aisle, looking at those daily diet choices we all make just to satisfy our sweet tooth. But we definitely aren't stopping there. Oh no, we are zooming all the way down to the microscopic, cellular level of the human brain to see exactly what those choices are doing inside our bodies. If you have ever reached for a diet soda or a sugar-free snack, trust me, you're going to want to pay super close attention to this. So, are 0 calories actually costing you your brain health? It's a pretty heavy thought, right? Today, we are framing this entire explainer as a totally objective, scientific cost-benefit analysis. We're going to look strictly at the data to see what really happens when we trick our bodies with artificial sweeteners. The big question is avoiding sugar actually worth the biological trade-off? Let's dive in and find out. Section 1, the sweet trade-off, weighing the everyday pros and cons. Look, let's start off by validating exactly why these products are so insanely popular in the first place. On the pro side, artificial sweeteners are incredible tools. They do not spike your blood glucose or insulin, which makes them literal game changers for diabetes management. They prevent tooth decay, and they can absolutely help create that calorie deficit you might need for initial weight loss. But here's the catch. These are stepping stones, they are not health foods. Check out the cons. Long-term use can actually alter your gut bacteria. Sugar alcohols like erythritol can cause some seriously uncomfortable digestive distress. And because these substitutes are hundreds of times sweeter than regular table sugar, they constantly mute your natural sweetness thresholds. That means naturally sweet foods like fresh fruit suddenly start tasting completely bland to you. So it is a real trade-off. Section 2. Inside the brain. Aspartame at the cellular level. To really understand what's happening microscopically, we're diving into a fascinating study from the International Journal of High School Research that looked directly at human brain cells. When you compare brain cells exposed to aspartame against cells exposed to glucose over an 8-day period, the difference is wild. At lower concentrations, around 5%, the cells look totally normal. But when you bump that up to the 25% and 50% aspartame concentrations, you can objectively see a severe scattering of cells and a massive decline in cell density, which points straight to cell death. Meanwhile, the glucose control group, even at those super high concentrations, stays much denser and healthier. Now, it's definitely important to mention that these 50% concentrations are extreme. They simulate a worst-case lab scenario to find the maximum potential for toxicity. But still, the visual contrast in the data is just undeniably striking. And the damage observed in the study actually goes way beyond just cell death. Through RNA sequencing, researchers discovered that aspartame altered the expression of 1,052 different genes. Specifically, it overexpressed genes tied to the mediated-independent toll-like receptor signaling pathway. Okay, I know that sounds like a massive mouthful of scientific jargon, but just think of this pathway like a giant fire alarm inside your cells. It is heavily linked to inflammation. So this data suggests aspartame can actually upregulate inflammatory responses right inside your neuronal cells, potentially throwing off the overall homeostasis or balance of your entire brain. But it doesn't stop there. While aspartame is busy sounding that inflammatory fire alarm, it is simultaneously deactivating other crucial genes. The study documented that 741 genes were underexpressed. We're talking about genes responsible for your most fundamental metabolic processes and ribosome biogenesis, which is basically how our cells produce RNA and proteins. Since recent medical studies actually link disruptions in these specific ribosome genes to human cancer, the researchers noted some very objective, documented concerns about a potential association between heavy aspartame consumption and risks to your long-term brain health. Section 3. The methanol problem. Breaking down the chemical culprits. So we've seen the cellular damage, but we really need to understand exactly which part of the sweetener is causing all this chaos. Aspartame is made up of 50% phenylalanine and 40% aspartic acid, both of which can mess with your neurotransmitters and neuron excitability. But I want you to focus on that remaining 10% slice, methanol. Despite being the smallest piece of the pie, methanol poses by far the greatest toxic threat to the human body. When researchers isolated that specific threat and exposed human brain cells to just the methanol component, the results were drastic. Compared to the dense, healthy cells you'd see in a control group or with the other chemicals, the methanol exposure causes a terrifying increase in round, dead cells. The live cell count absolutely plummeted to just 1.85 times 10 to the fourth cells per milliliter. It's pretty clear.
Methanol is the main chemical culprit driving this neurotoxic effect.
To understand why methanol is so uniquely destructive, listen to this striking quote from the research. Methanol metabolizes into formate in the body. This formate can be metabolized into formaldehyde, detopiperazine, try saying that 3 times fast, right? By the way, that's a known carcinogen, and other highly toxic compounds. This right here is the biological mechanism. Once ingested, methanol breaks down into highly oxidative, toxic substances that can literally cross the blood-brain barrier. And that localized accumulation in the brain is exactly what causes the severe cellular stress and cell death we just talked about. Section 4, the migraine connection, triggers, and the stacking effect. Okay, so how does all this microscopic neurotoxicity actually manifest in your day-to-day life? Well, it often connects to a very common, very painful real-world symptom. Based on clinical insights from Dr. Fred Cohen, who is a prominent headache specialist in New York City, artificial sweeteners, specifically aspartame and sucralose, which you probably know best as Splenda, are frequently reported as triggers for severe headache and migraine attacks. For some people, just consuming these products can bring on a massive migraine within a few hours. So how exactly are these sweet little packets causing such intense head pain? Let's break down the 3 main triggers. First, neurochemical shifts. These synthetic compounds can alter neurotransmitter levels, like serotonin, and overexcite the trigeminal nerve pathway. Second, the gut-brain axis. Like we mentioned earlier, messing with your gut bacteria triggers systemic inflammation, which communicates directly with your brain and lowers your headache threshold. And finally, my absolute favorite concept, the stacking effect. Think of your diet and your daily life like a bucket. One diet soda, probably perfectly fine. But if you pour that diet soda into a bucket that's already filled to the absolute rim with stress, dehydration, and a terrible night's sleep, boom, the bucket overflows. That sweetener becomes the final drop that triggers the migraine. Section 5. Choosing your sweetener. Making informed dietary choices. All right, we have unpacked a lot of intense cellular and clinical data today, so let's make this actionable for you. This is your ultimate cheat sheet for the big 3 alternatives: stevia, sucralose, and monk fruit. Let's take a quick look at how they stack up against each other. This is going to help you find the right tool for your specific diet, based on their origins, taste profiles, gut impacts, and of course, price points. Let's start with stevia. The biggest thing here is that it's a plant-based, affordable, and natural option that absolutely will not spike your blood sugar. But it does have a rather unique genetic quirk. You know how cilantro tastes like soap to some people? Well, about 20 to 25% of the population has a genetic variation that makes stevia taste super bitter, kind of like metallic licorice. Also, a quick warning, be careful in the grocery store. Packaged powdered stevia is really often blended with sugar alcohols like erythritol as a cheap filler, and that's exactly what causes that upset stomach we warned you about earlier. Next up is sucralose, most commonly sold as Splenda. Now, this is the budget-friendly, undisputed king of high-temperature baking. It holds up exceptionally well in the oven and tastes remarkably close to real sugar. But you really have to weigh the cons here. It is fully synthetic, created by chemically modifying sugar with chlorine. Yeah, chlorine. And even more importantly, clinical studies suggest that long-term use of sucralose might actually alter your beneficial gut bacteria and could potentially disrupt your glucose tolerance over time. Finally, let's talk about monk fruit. This is widely considered the premium, absolute ideal choice if your budget allows for it. It has the cleanest taste, it has literally 0 negative impact on your gut, and its sweetness actually comes from unique compounds called magrosides, which have mild anti-inflammatory properties. The main catch? It's pretty expensive. And because pure monk fruit extract is just so intensely concentrated, you absolutely must read the labels. Store-bought versions are almost always cut with bulking fillers just so they measure out nicely like regular sugar. Which brings us to one final provocative question to leave you with today. Will you shift your palate, or are you going to keep paying the sweet trade-off? Artificial sweeteners are undeniably helpful tools for cutting calories and managing things like diabetes in the short term. But as we've seen from the cellular data all the way to the migraine clinic, they carry a hidden biological cost. Ultimately, the healthiest long-term goal isn't just swapping out one sweet powder for another, it's training your palate to actually enjoy things like naturally flavored water and unsweetened teas. The data is out there, and the cost-benefit analysis, well, that is entirely up to you. Thanks so much for joining us for this explainer, and we will catch you next time.